In the previous video, we discussed what was required to do if you've mentioned the word velocity or if you've mentioned the word acceleration and what we're supposed to use in terms of those. Okay, so now I'd like to put that into actual practice in terms of a real example, just so you can see what we actually mean. Okay, I've got an example here where we're talking about a ball which is thrown into the air, and it's given by, whoops, let's just reduce that. It's given by the formula h of t is equal to negative 5t squared plus 59t over 2 plus 3, okay? Where the t variable is the time given in seconds and the h variable is the height in meters. So, if you throw a ball, it's always going to have some kind of like parabola shape, okay? And essentially the idea would be this: if you were to draw an x and a y axis underneath that, this y axis, if that was the starting point to where the ball started and where it finished, and this is the vertical y-axis to where the height of the ball is, this axis over here is going to represent the time taken, and this axis over here is going to represent the height of the ball. So how high is the ball after 1 second, after 2 seconds, after 3 seconds, and so on. Okay, right, so that's the equation representing the pathway that the ball took, and this is now what we have to do. So question 1. Determine the height of the ball above the ground after 2 seconds. Have they mentioned the word velocity? No, okay, they haven't. They just want to know what's the height of the ball after 2 seconds. Well, if that's the case, for me to work out the height of the ball after 2 seconds, I'm going to take my formula and I'm going to substitute 2 in place of t, and well, really just work it out. So we've got 59 times by 2 over 2 plus 3. And what does that work out to be? Well, if you do that calculation, we're getting 42 meters high. So after 2 seconds of being in the air, all right, the ball is at 42 meters high. Okay, so great, that's what we worked out. Determine the average speed of the ball during the first 2 seconds. The word seconds has jumped down there. Right. The average speed of the ball during the first 2 seconds. Okay, average speed, all right? Remember right back in the beginning of calculus, we spoke about average rate of change as opposed to rate of change at one specific point. That was the difference between your average gradient and your gradient of a tangent, which is obviously your derivative, okay? Well, what do we know about the first 2 seconds? Well, in the first 2 seconds would mean that starting off, the time would have to be 0, going up to the time of being 2 seconds, right? So that's fine. So I know that I'm looking between where the time was 0 seconds up to where, okay, this is just an estimate, but where the time would be 2 seconds. What is the average rate of change between your ball? Okay, so do you remember that to work out average gradient is really a case of working out y1 minus y2 over x1 minus x2. So in order to do that, I've got 2 x coordinates. What I'm missing are the 2 y coordinates. Okay, so pretty simple. All that we have to do to work out those y coordinates is we have to substitute each of those t's into the equation, and you'll get the y coordinates. Okay, by substituting 0 into the equation, you're going to land up with 3 as your y coordinates, and by substituting in 0, which in fact we have already sorry, not 0, 2 into the equation, which we've already done, we worked out that that was 42. So that's actually your 2 points that we're going to use to find the average speed. Okay, so pretty much here's the story. y1 minus y2 over x1 minus x2. No, wait, I didn't get that right. Let's just check myself here. Over x1 minus x2. Always got to be very careful of that. We're going to land up with 39 over 2, which if we work it out as a decimal is 19.5 meters per, oh, can't fit that in, meters per second. Okay, so what's the average speed that the ball is traveling between the point at which no time had passed and 2 seconds had gone past, the average rate of change of your ball was 19.5 meters per second. Okay. Now it says, what's the velocity of the ball after 2 seconds? Okay. The word velocity, as I said to you, can be interchanged with the word speed. It can be interchanged with the word rate of change, with gradient. These all mean the same thing. So what is the velocity of the ball after 2 seconds? So can you see the difference between this question and the previous question? Is the previous question said in the first 2 seconds, which meant that it was from 0 to 2. Here, I want to know at 2 seconds, so at that 1 point. So do you agree, if I'm looking for the rate of change at 1 point, I'm looking for derivative, okay? So we're going to have to take the derivative of your formula, which is going to be the following. The derivative is going to be h prime t is equal to, it is negative 10 t plus 59 over 2, okay? And basically we want to know what is it at 2 seconds. So you have to substitute 2 into each of these, or into just that t over there actually, and we're landing up with 9.5 meters per second. Okay, so the ball at exactly 2 seconds is traveling at a speed of 9.5 meters per second. Okay, what is the acceleration of the ball after 2 seconds? Well, acceleration is the rate of change of your rate of change. Okay, so that requires us to find our second derivative. So we're going to find the second derivative of this function, which actually just gets us down to negative 10, okay, as the second derivative. That's your acceleration, okay? Now, the negative is going to indicate that the ball is actually slowing down at that point. So if you think about the path of a ball, if you throw a ball up into the air, it goes quite quickly, and then it actually does start to slow down because there's actually a point at which it actually, for a split second, hangs in the air, and then it turns around and it comes back down again. And as it comes back down, it'll obviously start increasing in speed. So as the ball was thrown up and it kind of reached its highest point, the acceleration slowed down, but as it turns around, it would speed up again. So at that 2 seconds, your acceleration is negative 10. At what time did the ball reach its maximum height, and what was the maximum height? Well, by now, I hope you realize that if you're looking for maximum, it's a standard deal. We're looking for derivative equals 0, okay? So we need to take the derivative of the h of t formula and we have to make it equal to 0, okay? So negative 10t plus 59 over 2, that's the derivative. I'm letting it equal 0. What is that giving me? I'm going to move my fraction over to the other side. That's giving me negative 59 over 2. And if I solve for t, I'm going to land up with a negative 59 over 20. And obviously as a decimal, probably the better way to look at it, 2.95 seconds. So how long did it take for the ball to reach its maximum height? 2.95 seconds. What was the maximum height? Well, what you're going to do is you're going to take that 2.95 seconds and you're going to put it into the t's of your original equation, and that'll actually give you the height of the ball at its maximum. Okay, so a really nice example of, and a really typical example of velocity, of acceleration, of maximum height. But again, remember, velocity, speed, rate of change, gradient, all mean work with your first derivative. Acceleration means work with your second derivative. A negative acceleration means it's slowing down. Positive acceleration, obviously it's speeding up. All right, there we go. I hope that makes sense. Keep practicing that, but you'll find that the more you do it, the more those words will keep coming up, and you'll recognize them. You'll see how easy it actually lands up being. Well done, you're doing an awesome job. Keep at it. I know it's a lot of work, but calculus is worth it, so keep practicing. See you next time.